Hello, guys. Yes, hey, good evening to all of you, those who have joined. As we wait for some of your friends to join again, I've written down some properties. That's what the topic is today. Properties of determinants. Very, very important topic. It's very interesting also. And then basically, we have one a solid 4 mark question from this topic. So, as you wait for your friends, you can take out your pen, book, paper. Chalo. You can write down some of the properties that I've written down already for you. Don't worry, I'll be explaining about this. So you can write down the notes. Patikreno, Priyanshu, Imli Mongla, Nasana, Nanuina, Ronsen, Imsotila, Ati, Satiala, Vendala, Timula, Tinutamsen, Shivella, Kinkali, Timsumala, Bendangamlari, Shipongala, Alanongla. Very good evening to all of you, Tunjun Zulu. Good evening. It's good to see all of you turning up for your classes, leaving aside all of your other works and then turning up for your classes, which definitely proves that you are also concerned about your studies. So it's really good to see that. I'm motivated again, as always. You guys never fail to motivate me, don't you? Especially, right? That was Jungla also. Good evening. You can note down some of the properties. There are around about 8 to 9 properties of determinants. We will be using all of them. So since the space is less, I've written down some of the properties in advance so that you can write it down as we just maybe wait for a couple of more minutes for your other friends also to join in. Good evening, super music. Okay, that's anyway. Imsanullah. Good evening, all of you. So basically, most of the important questions for our board, for the Nagaland Board of School Education, is from this chapter only, chapter 4. Because in chapter 4, we will be learning about these properties of determinants. So from there, usually we used to have one 4 mark question. Then as we move on, we'll be moving on to now adjoint of a matrix very soon after these properties of determinants, where we'll be learning, how to find out the minor of a matrix, adjoint of a matrix, which will in turn give us the other method to find out the inverse of a matrix, which basically for our board will be set for 6 mark questions. So this chapter is very important. So try not to miss any of the classes. Of course, you can always watch the recorded video also. So that's the advantage. You can attend live classes. Plus, whenever you have doubts, you can go through the other topics, other downloaded videos. Sangeeta, good evening. Sunjami, good evening. I also have another request also to make to each and every one of you. Like unlike you, there will be many students, especially during this lockdown, especially class 12 science students. There will be many students who I'm sure will be facing a lot of difficulties, and we know everybody cannot afford tuitions. So these classes, as we all know, are for free. So please, I will need your help. Please help me reach out to them so that they can also benefit from what we are doing here. So please, I will need definitely all of your help to kindly support me, which you're always doing, and help me reach out to maximum of your other friends also who are outside, so that they can also have a source to study regularly. So kindly, please do help me share this particular channel also. I'll need that help, okay, so that we can reach out to all of them. Achit Pawan, good evening. I believe all of you are very busy writing down the notes, so that's good. Write it down, write it down. There are, as I say, around about 8 notes. I believe you have already done your practice with the matrices. Some questions on the topic of matrix. I think exercise 3.4. Some questions are there. I'll be very soon uploading those questions also. And of course, I'll be continuing with the topic of continuity also very soon. Maybe by this weekend, I'll get some time. So by this weekend, I'll try and upload more videos, fresh videos. You can watch that at your own convenience. Intiala also, good evening. So, all right then. So I guess it's time to begin our session for today. I don't think we will be able to solve all the questions from this particular exercise because there are many questions and these questions are quite big also. So we'll try to do it in 2 sessions. Today we'll do the properties, learn some of the good evening. Today we'll try to do some of the properties plus more questions, and we'll do one more session if I think so. I think we will need definitely one more session to solve the remaining part of the exercises. I will try to solve each and every question from the exercises. So do continue to motivate me like this. Definitely I'll be doing everything that I can. And yeah, thank you for your likes, so many likes. So thank you for that. Diha, good evening. Diha Giri, yeah, good evening. All right then, so shall we begin? I guess all of you are ready now. Chalo, let us begin with this new topic, that is properties of determinants. It's going to be slightly, similar to that property, that inverse of the matrix, elementary row transformations, if you remember. So operations will be slightly similar to that. I'll be moving aside from the board as of now because some of you might still be writing it down. So I'll be that invisible man talking to you. So definitely, like it's going to be slightly similar, the operations, but yes, we do have lots of properties which will help us to find out. Basically, these properties are for what? Up to class 12 standard. As we have seen in the previous exercise, the introduction exercises, we have seen how to find out the determinant. What we have seen, what is the determinant? We have seen how to find out the determinants. Once again, thank you for all of your likes, so many likes. So determinants, actually what happens is a value that we have learned how to calculate for 3x3 matrices, 2x2 matrices and all. But all the values of the determinants are not easily expressible or cannot be easily calculated just by simple expansion. So that's where this properties comes into effect, which will help us to reduce the determinants, help us to solve and find out the values of determinants. So up to 12 standard, basically that's the importance of these properties. Higher classes, it will have much more meaning again. So these are all right. Let's continue then. So the first property that you have seen, the first property that you have already seen is determinant. If rows and columns of a determinant, I've written it in short only. If rows and columns of a determinant are interchanged, then the value of the determinant remains unchanged. That means the value of that particular determinant, if you interchange a row and a column, exchange, then the value of the determinant remains the same. As we have seen, determinant is nothing but a value only. So suppose the value of a determinant, like last time by expansion, if you get 30, just for example, then that same determinant, if I just exchange one row to its column and row, if I just exchange, then the value will remain 30 only. That's what it means. All right, so maybe like I can give you one example. I hope you have written it down. Chalo. Okay, so I can give you one example, like I think first property is done. So one example will be like, suppose if not a matrix, okay, determinant. So the straight line bracket is important. Suppose 2 1 2 1. I'm not going to solve it. Okay, 2 3 1. Let us just assume the value of the determinant we already know. So what happens here is, suppose if I plan to exchange, this is how we will denote both side arrows, row 1 and column 1. Let us just assume that maybe this value is, let's say, some value x, 30, 40, 50, we do not know. Then if I just exchange the rows and columns, of course I'm not going to be writing it here, I'll be writing it here. So if I decide to exchange the rows and columns, row 1 and C1, if I just exchange, what will happen is, so row 1 will go to column 1, 2, 1, 2, and column 1 will go to row 1, that is again 2, 1, 2. These values will remain the same. So I've exchanged row 1 to column 1 and column 1 to row 1. After this also, what you will find is, you can check out for yourself also, you can find, what you will find is the value of the determinant will remain the same only, that is whatever quantity it is, that is x only. Alright, so that's what it means. So we will need all these properties. Okay, Atan, Atan, good evening. So that's the first property for you. Now the second property is, don't confuse with this, okay? Second property is, if any two rows or, not and, or columns of a determinant in short, are interchanged, then the value of such determinant becomes negative of itself. That is, if I exchange a row, if I exchange two rows, that is, if I exchange row 1, I've given you an example here itself. So what I've done is, suppose if this is a determinant, A, B, C, D, E, F, G, rows, 3 rows and 3 columns, and what I've done is I've exchanged only with rows, not with columns, okay, not like the first one, rows with columns, no, just 2 rows, row 1 and row 2 I've exchanged, that is row 1, I've brought it down to row 2, row 2 I've brought it down to row 1. What happens then? The value of the determinant, value will remain the same, the magnitude will remain the same, but a negative sign. So every time you exchange 2 rows, or 2 columns, you will always have to bring about a minus sign, negative sign. So we'll get to see more of this when we solve the exercises. So that time, of course, you'll get used to it. Third property states, if all elements of any 2 rows or columns of a determinant are identical or same. We'll have another extension of this property that's called proportionality also. If all elements of any 2 rows or columns of a determinant are identical or same, then the value of the determinant is 0. You don't have to calculate also. It's going to be 0. Best example, suppose you have a determinant 1, 2, 3, 4, 5, 6, 1, 2, 3. Now what you will see here is row 1 and row 2. Row 1 and row 3. They are same. Isn't it? 1, 2, 3, 1, 2, 3. So this value, no need to expand also, you will get 0. So that's what the property gives states. Alright. So these are the first 3 properties. Keep that, we will keep that reserved for us. We are going to need that, okay, for our better solution. Alright, the next property number 4. Let's write down. That's also important. That is property number 4. It says, if every element of any row or column, I'll just write it in short now, RNC, of any row or column of a determinant is, I'm writing it in short only so as to save some time, is multiplied by a constant. This property is important, okay? It basically used in multiple choice questions. By a constant k, then the value of the new determinant, is k times the value of the original determinant. Is k times the value of the original determinant. If every element of a row or a column is of a determinant is multiplied by a constant k, any constant, then the value of the new determinant is k times the value of the original determinant. Another example, just an example only. That is, suppose you have a determinant, let's say 1, 2, 3, 4, 5, 6, 1, 3, 4, for example. Okay, we'll not waste time calculating all this stuff, just an example. So suppose the value of this determinant, let's say value of this determinant, suppose, okay, alright, suppose this value was, let's say 10. Then if I multiply, if I multiply maybe row 1 by 3, every element of a row or a column. So if I multiply row 1 by 3, then that's going to be 3, 6, 9. The other values remain the same, 4, 5, 6, 1, 3, 4. Then what will happen is, without expansion also, what we can do is, if we happen to know the value of the original value of the determinant, and then we have multiplied a particular row by maybe a constant k is equal to 3, then what will happen is, the value of the determinant also will be multiplied by 3 times of the value of the original determinant. So that value is going to be 30. All right. So with this, of course, what happens is we get one important note. All right. So by this property, I'll just write directly, that is, we can take out any common factor. Okay, we can take out any common factor from any one row or column which was not allowed in matrices. Okay, which was not allowed in matrices. So we can, by this property, of course, we can take out any common factor from any one row or column of a given determinant. Alright, by that what we mean is, for example, 2, 4, 6, 1, 2, 3, 7, 8, 9. So what we can do here is, from this particular determinant, I can see that 2 is a common factor in row 1. So that we can take out, because the value of the determinant also will be just multiplied by 2 only. And that means 1, 2, 3, 1, 2, 3, 7, 8, 9. That can be done. Of course, its value will be 0, so we're just taking some random examples. Alright, so we can do that with determinants. So with that, I'll give you one theorem, that is, if B, maybe another note which is very much used in multiple choice questions. Okay, so if B is a square matrix, if B is a square matrix of order n, if B is a square matrix of order n, then the determinant of k times of the matrix B, k times, this is inside the determinant, so this is going to be k times of the matrix B. What happens with the matrix? We multiply with the scalar, the entire elements, all the elements gets multiplied with that scalar, isn't it? Right. So this will be k times k power n into the value of the determinant B, where k of course represents the order of the given matrix. Alright, I mean n. Now that means, for example, suppose if B is a matrix of order, let's say 3, then what will we have? K times of B will be, where k is any scalar, that's going to be k power 3 B. So that's very much understood, because if I take, see, this is the order of a 3 by 3 matrix, then according to that property, Suppose 2, 4, 6, 8, 10, 12, 6, 4, 2. So see, if I take 2 common, I can take out from one row. So that's going to be 1, 2, 3. Again, if I take 2 from row 2, that's going to be another 2. Now, because every element, every row, every column will be separately. A common factor will have to take out separately. So that's going to be 4, 5, 6. And again, from row 3, if I take out 2 common, so that's going to be 3, 2, 1. So you see what happens here? This was an order matrix of order 3 by 3. So it's like 2 cubed into the value of that determinant, that previous same determinant. Alright, so this is what the property means. As we solve more questions, when we solve the exercises, definitely there is bound to be some confusions now because we are not doing the exercises. So as we solve the exercises, definitely all those doubts will be clear. Don't worry. Property number 5. If all the elements of any 2 rows or columns, if all the elements of any 2 rows or columns of a determinant are proportional, P-R-O-P-O-R-T-I-O-N-A-L, are proportional, then the value of such determinant becomes 0. So this is like a slight extension of 2 previous properties. What it means is very simple, that is 1, 2, 3, 4, 5, 6, 2, 4, 6. So, see, you can see that these 2 rows, row 1 and row 3, are proportional, isn't it? 1 is to 2, 2 by 4 means 1 is to 2, 3 by 6 means 1 is to 2. Or in other words, if I just take 2 common from the third row, if I take 2 common from the third row, 1, 2, 3, 4, 5, 6, 1, 2, 3. So if they are proportional, definitely you will come across this result, and this result is what we have seen from one property, that if any 2 rows or any 2 columns of a particular determinant is equal or identical or same, then the value of the determinant is nothing but 0. Alright, I hope you're noting down all the properties. Next, property number 6. Property number 6. If all the elements of any row or column of a determinant are 0, then the value of the determinant is 0. A simple property again. Then the value of the determinant is 0. That means if you have a determinant where maybe one row is completely 0, one column is completely 0, and then you have like some elements, then this value will be just what? 0. Okay? Done? Alright. Next property, that's going to be, I think, property how much now? Property number 7, I guess, right? 7. No? Next. If this is also important again, if all the properties are important, definitely. If some or all the elements, if some or all the elements of any row or column, of a determinant are expressed as the sum are expressed as, let's say, as a sum of two or more terms, then such determinant can be expressed as a sum of two or more determinants of the same order. If some or all the elements of any rows or columns of a determinant are expressed as a sum of two or more terms, then such determinant can be expressed as a sum of two or more determinants of the same order. Don't worry, I'll be explaining to you exactly what this means. First, write it down. Done? Okay. Now here what this property really means. It means, suppose you have a determinant. Okay, suppose you have a determinant, let's say A, B, C, where in one row, what happens is, every element is expressed as a sum of, let's say, two elements. So suppose you have a determinant like this, A, B, C. Second row is expressed as a sum of two elements, D plus E, F plus G, H plus I, J, K, N. Then what we can do is, as per the property, what we can do is we can expand this determinant as the sum of two determinants of the same order with these elements distributed or broken or stretched apart into two determinants. That is, these elements will not change. Row 1 and row 3 elements will not change. But the row 2 elements, what we can do is we can express that as a sum of two separate determinants. That is D plus E, F, G, H, I. Alright, so this is one property that can be used. Okay, so definitely there are some problems based on these properties. We will be definitely doing all those properties. Utilizing, making the most of all these properties. So it's actually not about by-hearting these properties, it's actually about like doing more and more problems, exercises, practice, then all these properties. As I said in matrix, the more problems you solve, the more varieties you come across, different kinds of questions, how to solve all those kinds of questions. Alright, another property which I'll not give you the description, like another property is what we can do is just like matrices, we can add particular rows to rows and columns to columns, corresponding elements. That is, in simple words, I'll just give you the notation that is to a particular row, Ri plus k times of R J, that this kind of operations. We have already done that in elementary row operations. Same can be done for column operations also. Of course, here what is the advantage? Another advantage, but another advantage would be like you can go for column operations also. Okay, it happens in columns as well as rows, no problem. Just stick to the properties first. So we can add. We have already done this in matrices while finding out the inverse of a matrix using elementary row transformation. So that's why I'll not give you the description of this. I'll just let you know that okay, this is also possible or something like that. Okay. Another property you can write down, not a property, like a note. If we multiply, if we just multiply, if we just multiply any row or column, if we just multiply any row or column by a constant. Remember, these are properties, but like it's something like if I just multiply r1 by, maybe something like if I just apply r1 as like 3 times of r1. Now we know that basically that will create imbalance with the determinant or any kind of matrix equation. You just cannot add or multiply values. So for that, what should happen is, if we multiply any two, that I think everybody understands, 12 standard, no? So if we multiply any row or column by a constant k, okay, by a constant k, then I'll just write here, we also divide the whole determinant by k. So multiplying and dividing. So this kind of operations we all know, isn't it? So multiplying and dividing. So if I multiply maybe row 1 by 3, then the value of the determinant should be again divided by 3 also. Alright, if we just multiply and if we just plan on multiplying any particular row by maybe just a constant 3, 5, then in that case, of course, yes, I'll have to divide the value of the determinant also by 3. Alright, that's only when we multiply, or maybe divide. So if we divide, then we'll have to multiply the value of the determinant by that particular constant. Okay? Alright, so these are some of the properties. As I say again, some of the properties. And if we need more properties, yeah, definitely when we solve the exercises, questions, that time, yes, we will learn about those properties if there are more extensions to the properties. Alright then, so let's get ready with the exercises. Let's see how many problems we can solve today. So let's go to exercise 4.2. You can all get ready. Let's go to exercise 4.2. Alright, exercise 4.2. First question. So I think let me just write down, because some of you may not have the textbook as of yet. So using of course you can download also, I guess, using the property of determinants, and so this is one condition here. You can use the properties, but you will not expand. Expanding is not allowed here. So using the properties of determinants and actually without expanding. Without expanding, prove that the first one, determinant of this matrix x, y, z, a, b, c, determinant, okay, x plus a, y plus b, z plus c is 0. So you will use any one of the properties. Okay, so we'll have to get this value as 0. So I'll just start with here. That is like, delta equal to this value. So then I have to get this determinant as 0 without expanding it. You can use the properties, yes, but you're not allowed to expand. That's important. So when the question says you're not allowed to expand, you're not allowed to expand. So what can be done here? What if I apply this operation like C3, column 3, if I just apply column 3 minus column 1, let's see what we have. So that means I'm going to change only column 3. So what did I tell you always? Except the column which or the row which you're going to change, the other rows which you're not planning to change, first write down those rows. You have to be very systematic. So column 2 and column 1 I'm not changing. So X, Y, Z I'll not be changing. This also I'll not be changing. Now we can do directly now because we have already done enough of elementary transformations. So if I just subtract X minus A minus X, I'll be left with A. Y plus B minus B. So Y cancel, I'll be left with B. This also I'll be left with C. So what do we have here? Look closely. I think there will be one property. This is the last property that we are applying. Okay, that last property which I gave you by notations and all. Nah? We've already done that in elementary row transformations in matrices, isn't it? So that's why. So you can see here column 2 and column 3 are equal, isn't it? Are same. So what will be the value of the determinant as the proof demands? 0, because column 2 and column 3 are, we can just write same, are same. Bus. So we did not expand, but using the properties, yes, we got the value of the determinant as 0. So it's not very complicated as you think it might be. It's quite simple. Number 2. I'll just write on the determinant straight up. A minus B, B minus C, C minus A, B minus C, C minus A minus B, C minus A minus B, B minus C. This also you have to prove that the value of this determinant is also 0. Okay, so I'm going to just write down like let delta equal to this. Let delta equal to this value. So now let's think of using which operation so that we can calculate and then maybe we'll get 0. We have here, see, like A minus B. So if I just add these 3 columns, so minus minus cancel, C cancel, minus A I can cancel. So if there's one property that we have seen, that is if all the elements of any particular row or column happen to be 0, then the value of the determinant is also 0. And that is what the proof is also all about, this particular question. So that means what I'll do is I'll apply column, maybe in any one of the columns it will work out. But I'll just apply here. Column 1, I'll represent as column 1 plus column 2 plus column 3. So, okay, since I'll need more space here, I'll just start with column 1. Okay, so column 1, that's going to be A minus B plus B minus C plus C minus A. Corresponding elements. B minus C plus C minus A plus A minus B. The other elements will not change. The other rows, I mean. Since all the elements of column 1 are 0, the value of the determinant is also 0, so that's the proof. Okay? Alright. Let's look at number 3. I'm going to write straight directly, because here also we are asked to prove that this determinant is 0. So we are asked to prove that the value of this determinant is also 0. So that's why I'm just writing directly the left hand side, that is let delta equal to this value. Think what can be done again. Remember, we are not allowed to expand. If we were just allowed to expand, then maybe this kind of determinant, just by expanding, we can just get the value of the determinant as 0 without actually using the properties also. But we are told use the properties, don't expand also. There's so many conditions. So it's like lockdown but no lockdown, something like that. Anyway, isn't it? Lockdown but no lockdown. So solve but no expansion, use properties only. So yeah, so that's why practice makes everything to be perfection. So practice, it's all about practice only. What can be done? Okay, I have something working out that's like 65 minus 63, 2. 75 minus 72, 2. 75 minus 72, that's 3. 86 minus 81, that's going to be 5. You getting what I'm trying to give you here? I'm going to apply this operation, column 3. I'm going to apply column 3 minus 9 sevens are 63, 9 eights are 72, 9 nines are 81. 9 times of column 2. You got that now? Isn't it? That's what I was calculating. 65 minus 63, 75 minus 72, 86 minus 81. So then, because 9 sevens are 63, I'm just going to write here, 9 sevens are 63, 9 eights are 72, 9 nines are 81. So 65 minus 63, 2. 75 minus 72, 3. 86 minus 81, 5. Now again, what do you see? 0, because column 1 and column 3 are identical again. So if you know how to use the properties, it is very simple. Okay, chalo. Number 4. Each and every question is different here, so that's why, as I promised, I'll solve every single question from this exercise with your motivation. So here also the question is, prove that the value of this determinant is 0. Again 0. So I think they are very fond of 0. So again 0. So I'm not writing that part. Alright. So chalo. But before that, I'll just do something that maybe I'll just expand and see. Open up. AB plus AC. BC plus. And I'm not saying that there is only one method to solve the question. No, there can be different ways. Okay, I'm thinking of something. Let's see if it works out. Column 3 again, I guess we're getting very fond of column 3. So column 3, I'll just add with column 2. So what I'll have here is AB plus BC plus AC. No, arranging and writing also. That looks much better. So AB plus BC plus AC. Column this also AB plus BC plus AC. It's all the same. So as I'm writing, I'm just arranging and writing simultaneously. Huh? Here also it's AB plus BC plus SAC. These are all addition terms, so that's why. So we see that in column 3, all the terms, all the elements of column 3 are equal. Of course, that doesn't prove that it is 0. At least 2 columns or 2 rows, all the elements should be 0. So this doesn't prove anything, but you see what happens. There was one property again, I've forgotten the serial number of the property, but there was one more property where it says that we can take out any, I think the property where we spend most of the time. We can take out any common factor from a common particular row or a particular column. You remember that? That's what I'm going to do here now. That is, since AB plus BC plus AC is common in this column 3, common element in this column 3, I'm going to take them out as the common factor. So what will be left? 1, 1, 1. BC, CA, AB, 1, 1, 1. So that's it, job done. So then this is AB plus BC plus AC into 0. Why 0? Why? Because column 1 and column 3 are same. I hope you're getting a feel to this question. Chalo, next question, that is number 1, 2, 3, 4, 5. So all questions, different properties. Number 5 is slightly different, so I'm going to write on the whole question for you. That is BC, B plus C, C plus A plus B. B plus C, C plus A plus B. Q plus R plus P, P plus Q. Y plus Z, Z plus X, X plus Y. Z plus X, X plus Y is equal to 2 times of A, B, C, P, Q, R, X, Y, Z. Alright, so some of you must be thinking, okay, I'm just going to expand. There was one property where we could express this sum, this determinant as the sum of 2 or more determinants. Yes, but look at this. Look at that example that I gave you. In that example, there was only that property where there's one property which says, since I will remind you of that, we're not going to be using that property, but in that property, you have seen that if a particular row or a column is expressed as a sum of 2 elements, then that particular determinant can also be expressed as a sum of 2 or more determinants. Particular row, I see. We can do that, but here, row-wise, column-wise, you'll have to proceed. So, like here, you just cannot express as like 2 determinants, because here you will expand this, that is 2. You'll expand this, another 2 more. You'll expand this, another 2 more. So if you keep on expanding, you'll have like around about 6 determinants that you will get, because it has to be like in one determinant. We just cannot do that because part by part we'll have to do. Alright, but nevertheless, we will not talk about that. Alright, so you've written down the statement. I'm going to straight go to let delta equal 2. First property, what was it? Number 1. Property number 1 that I gave you. If any particular row is exchanged with its column, then the determinant remains the same. Only when row and row are exchanged, minus sign comes. Only when column is exchanged, minus sign comes. Remember that, no? We're going to apply that first property. That is, I'll interchange all the rows to columns, columns to rows. Rows to columns, columns to rows. That is interchanging rows and columns. So I'll just start with this one. So b plus, stick to 1, otherwise you will confuse again. C plus a plus b. Next, q plus r plus p, z plus x. That means column 1 to row 1, column 2 to row 2, next column 3 to row 3, y plus z, z plus x, x plus y. Okay, so no sign changes because we have just exchanged the rows to columns, columns to rows. Now this is going to be a slightly complicated problem, but anyway we will work it out. Because the problem is we are not allowed to expand, that's why. And then we also have to get not a value. Remember, don't forget the proof. We have to get a determinant. So maybe what I'll do here is column 3, I'll exchange it with column 3 minus column 1 plus column 2. I'll just apply this operation. So column 1 and 2 I'm not going to be changing, because all these elements have to be individual, so I need to at least start with one element, one row or column. This, okay? So column 3 only I'm planning to change as column 3, I'll write here. Now, what I'm trying to tell you is column 3, I'll be subtracting with addition of column 2 and 3. B plus column 1 and 2, C plus A. So that's going to be A plus B minus 2C minus A. B. What is left? Minus 2C. Similarly, if we apply RR, so this is something wrong here. Q plus R, let me have a look. Q plus R plus P, I think this is going to be P plus Q. No, terms are slightly different. I think even I also, again, that's always usual with me. Isn't it Q plus R plus P? Yeah, P plus Q. So P plus Q, if I subtract from the sum of these two elements, P, Q cancel. So here also I'll have minus 2R. Here X, Y will go. So I'll have, I think, minus 2Z. Okay? Alright. Next, what can be done? I'll take minus 2 common from column 3. That can be done. You see how we work out this problem. Please practice. There can definitely, I am sure there will be more easier methods also. As of now, this is what I can do. Done? Now see, I have a singular element here. So C1, what if I apply C1 minus C3? Then B plus C minus C. So C3 will not change. So B plus C minus C, so I'll be left with B. Here QR minus R, so I'll be left with Q. Here YZ, Y plus Z, so I'll be left with Y. Similarly, C2, if I subtract from, minus C3, C plus A minus C, so I have A, R, so I have P, Z, I have X, almost there. almost there, but if you look at the proof, just a little bit of arrangement needs to be done. So what happens with the proof is A, B, C. We have A, B, C. Okay, A, B, C. Now if we can just exchange, I think we'll get the solution, Aram se. If I just exchange C1 with C2, just let's see. I'll just exchange C1 with C2, column 1 with column 2. A, P, X, B, Q, Y, C, R, Z. I've just exchanged column 1 with column 2, nothing much. Column 1 and column 2 I exchanged, but. Second property. Property number 2. Those I've written down. The property states if any two rows or any two columns are interchanged, then the value of the determinant changes by a negative value. So minus minus becomes plus 2. And here, almost there, so. Now again, if we go back to, was it really necessary in the beginning? Anyway, well, if we just exchange now, interchanging the rows and columns, going back to the first step again, that is, interchanging rows and columns. So I don't know, was it really necessary or not, but maybe after this, you can just give it a try by not interchanging the rows and columns. Because the first step what we did was we interchanged the rows into columns. Was it really necessary? I do not know. That was what came to my mind at that particular moment. So maybe, may not be. So you can give it a try without interchanging, no? Directly with almost, I guess, almost the same steps. You can give it a try. Maybe rows will change to columns. You can give it a try, you will know. Otherwise, this is also fine, no problem. So I'll interchange the rows to columns. So rows to columns, rows to columns. Anyway, we get the proof, we get the job done. And I'm just trying to experiment, curious mind, experiment. No, experiment on stuffs, experiment on things, because from failure only we learn. Once we make mistakes only, that's from where we start learning, right? That's the proof. AP. I guess that's the proof, isn't it? APX, BQY, CRZ. Yes, exactly. Alright, quickly let's move on to question number 6. So 6. Number 6. This value too we have to prove directly as 0. So I'm just writing the determinant only. So let me have a sip of water. So this value we just have to prove that it's just 0. So let directly y. So here I'll use one property. No, that's what is coming to my mind at the moment. So we'll just do that. As I say again, you can experiment. You'll get some more methods, I believe. Row 1, because C, I'll have to compare and then bring it same. So row 1, I will multiply by C. So that all the properties will be used. Huh? So that we get used to all the properties, so that's why. But if we multiply row 1 by C, then of course I'll have to divide by C also. The problem is we don't have to expand, and that's why. Without expansion, we have to do. Row 1, maybe row 1 minus b times of R2. What shall we have? As I say, we are doing this definitely from question number 8 and all, it will be much easier because there we can expand and then we can just solve here. We are not allowed to expand, so without expanding, we have to get the values. So we have to work out. So row 1, I will multiply with R1 minus B times of R2. R1 minus B times of R2. R1 minus B times of R2. So minus minus plus, so that's AB. This will not change because AC minus B times of 0, so that's going to be AC. This one minus BC minus B times of R3. So minus BC plus BC, that will give me 0. Done. Shall I rub this part? This rough calculation. Of course, from the operation, I think you can also manage because this is not the first time. Now you see, from row 1, I can take A common. No? So that's B, C, 0. Minus A, 0, minus C. B, C, 0. That is what I was trying to do here. Because without expanding, we have to prove that the value of the determinant is 0. So definitely this is 0 because R1 and R3 are identical. No, because BC 0, BC 0. So this value is 0. Got that? Okay, all right then. So I guess that should be enough for today. The rest of the questions I'm also exhausted. So the rest of the questions we will continue in the next session. That's the part 2, where it will be of course much more comfortable because they will be allowed to expand. So more freedom will be given to us. So that's basically from 8 onwards, 7, 8, 8 onwards. So so in one more session that should be done. All right, so thank you again, all of you, for joining in, enjoying the classes. I hope you have enjoyed the classes. Please do let me know also. So I hope you have enjoyed the classes, and yes, I'll see you again very soon with the second session. The second video, second part of this exercise, determinant exercise 4.2. Alright, so thank you each and every one of you. Do continue to motivate me, and yes, do share and with everyone, okay, so that everyone can avail this opportunity. So all right then, thank you so much for your warm response. Thank you, each and every one of you. Thank you, all of you. Yeah, enjoy your evening. A very good evening to all of you, and yes, have a good night's sleep, enjoy the rest, and yeah, happy weekend also. All right, okay then, bye bye, take care.